Good evening, students. Today I will continue with the next part of the semiconductor, that is the p-type semiconductor. So in the previous videos, I think already you know what is semiconductor, what is the types of semiconductor, that is intrinsic and extrinsic. Intrinsic is the pure type and extrinsic there are two types, that is p type and n type. Already n type already has been discussed. Today I will discuss the p type semiconductor. So in the n type semiconductor, I have said that it is being doped with the pentavalent compound, right, or pentavalent elements. As we are doping with the pentavalent element, so therefore there is one single electrons which is present in the conduction band. Therefore there is the large number of free electrons are present in the conduction band. So it is conducted, or the semiconductor is capable to conduct the electricity due to the presence of large number of electrons in the conduction band by applying a small amount of voltage, right? So this is the n-type semiconductor. As negative carriers, that is the electron acts as the carriers. Now coming for the p-type. For the p-type semiconductor, there we are doping with the trivalent elements. So as we are doping with the trivalent elements or trivalent atom, so therefore there is a deficiency of one electron in a particular point. So therefore in the conduction band there are deficiencies of electrons, but as there is the deficiency, it acts as the positive carriers, which is basically the holes. Okay, so let us understand this by a pictorial format. So suppose this is our conduction band and this is our valence band. So as we doped with the trivalent compound or trivalent atoms, then therefore some holes is being created here instead of electrons. So therefore then as we are giving some thermal energy, so these holes basically acts as the carrier in the conduction band, and the Fermi level comes near to the valence band. Okay, so this is called the non-generative p-type semiconductor. Okay, as here holes are the majority carriers, so it is called the p-type. Hopefully it is clear to all. Now the thing is that if I increase the thermal external energies, then this Fermi level goes down or overlaps this valence bond, then it is called the degenerated semiconductor. Okay, now I will discuss some certain definitions. First one is that mobility, current density, conductivity and mobility. Okay, so first thing, before going to that, I will discuss what is drift velocity. So what is drift velocity? If an electron moves under any external potential, then the motion of the electron is being regularized, and this kind of motion is called the drift velocity. Suppose number of electrons move in 1 second, that is if I consider NAVD. What is N? N is the number of electron or electronic concentration, and AVD is the volume through which electron is moving, right? So for I, it is can be written as this So therefore I by A EVD, and VD is the drift velocity, right? So this I by A, this is known as the current density. Okay, and this I by A is defined as current density and it is denoted as J. Okay, so you can say that the current per unit area, the current moving through a conductor per unit area is known as the current density. Okay, next is coming the mobility. So what is mobility? Mobility is defined by this mu, right? So mobility is defined as drift velocity by electric field. Okay, so according to the Ohm's law, this is basically the another version of Ohm's law. According to Ohm's law, V equals to IR, right? So here, according to Ohm's law, that can be defined as J equals to sigma E, right? So what is this sigma? Sigma is defined as the conductivity. Sigma is the conductivity. Okay, so these things basically, the conductivity, mobility, drift velocity, all these definitions is important. Okay, so up to this I am completing here. In the next video I will continue with the PN junction diode. Thank you.